Good afternoon, ladies and gentlemen. My name is Stefanos Vederinos, and I'll be taking you through business statistic today. I would want to concentrate on the mode and the measures of location. As you know from the previous lesson, if you didn't know, then I just urge you to go and watch the video. That the mode is part of the measures of location under descriptive statistic. So then we start with the group data, since we know that we have two different types of data, namely the group data and the ungrouped data. And first and foremost, let me just start with the formula for the mode. So where we are saying that the mode is the same as we have O subscript MO plus C times F minus F subscript M minus 1 divided by 2F minus F subscript M minus 1 minus F subscript M plus 1, where we are saying that our MO is the lower class limit of the modal class, and our C is the class width, our F is the frequency of the modal class, our Fn subscript M minus 1 is the frequency of the class preceding the modal class, where our 2F is the frequency of the modal class multiplied by 2, and our F subscript M plus 1 is the frequency of the class from the modal class. Here they give us the following data, which is representing the scores by learners in grade 10B. So then in the table given as displayed on the screen, we have 4 columns and 3 rows, and the first columns is denoting the test score class, and the second one is denoting the frequency, the third one is the midpoint, and the fourth one is the FM, which is our frequency times the midpoint. And then we have the class as follow. We have the class of 19 to 34. We have the class ranging from 35 to 50. The third class ranging from 51 to 66, and then the fourth class ranging from 67 to 82. And the frequency of class 19 to 34 is 5. The frequency of class 35 to 50 is 4. The frequency of class 51 to 66 is 2. And the frequency of the class of 67 to 82 is 3. If we add together the total frequency, we are going to get 14, and this will denote our N, which is the sample size. And just not to waste time, says now they are asking us to calculate the mode. Then we know, since the mode is equal to our O subscript MO plus our C times F minus F subscript M minus 1 divided by 2F minus F subscript M minus 1 minus F subscript plus 1, then our calculation will be as follows. So we are going to say that our lower class limit for the modal class is 19. So how did we get that? We look at the frequency, and then we are just saying that the modal class is the class with the highest frequency. In this regard, it will be the class of 19 to 34 because it has a frequency of 5, which is the highest frequency in this frequency column. So then the lower class limit for the class 19 to 34 is 19. So 19 will be our lower class limit, and you're going to display it here. And then from that, we are now going to find the class width. Then we are going to say that our class width is the difference between two lower class limit or the difference between two upper limit. So if we want to find it, then we are just going to say 35 minus 13, minus 19, then you're going to get 16. And then now the frequency of, and then we are going to times this 16 by the frequency of the model class, which is 5, and then the frequency of the class preceding the model class. Since we do not have any class preceding the model class, then it will be just 0 here. It will be just 0. And then we divide that by 2 times the frequency of the model class. The frequency of the model class is 5, so we are going to say 2 times 5. And then we minus the frequency of the class preceding the model class. And then I said, since that one is not appearing here, or we do not have a class preceding the model class, then it will be just 0. And then we minus again the frequency of the class following the model class. That will be 4. So the class that is following the model class is the class of 35 to 50, and it is having the frequency of 4. So we are going to minus 4 here. So if we did that, then we are going just to say it is equal to 19 plus the on top here. If we minus 16 times 5, it will give us 80, and then we divide this one. If we make 2 times 5 minus 0 minus 4, it will be 6. Now we are going to have 19 plus 80 divided by 6, which is the same as you have 19 plus 13.333, which is the same as you have 32.333. So now you can just conclude that most of the learners in grade 10B score between or scores 32.333. Just a little bit of recap. Just like to analyze the formula, this is just if you know you have 0 or you have O subscript MO, then you know it is the lower class limit. And if you have F subscript M minus 1, you know you have the frequency of the class preceding the model class. If you have the F subscript M plus 1, then you know is the frequency of the class following the model class. Then if you have F, you know is equal to the frequency of the model class. And if you have 2F, you know that is the frequency of the model class when it is multiplied by 2. So to that, we can just go to the ungrouped data. So under the ungrouped data, we are just saying that in ungrouped data, you're just given random data, and then they just ask you to pick up the model number or the mode, or to identify the mode ladder. So then they say they give you the following data for the scores for grade 10B student, and it is as follows: 19, 20, and so on. Since you can see these data are displayed in ascending order, that is from the smallest to the largest. So it is always urged or very important that you should always arrange your number in ascending order. So then the first question they just ask you to, what is the model test scores for grade 10 learner student, for grade 10B student. And then we just look at the data given, and then we pick the number that is appearing most. Then we know that will be just 79 because it's appearing twice. There's no any other number that is appearing twice, it's only 79. So then you're going to say our model class or our model number is 79. So we can just make a conclusion that most of the students in grade 10B score 79 in the test. And then now they can just ask you, is the data unimodal, bimodal, or multimodal? And then uh, from looking at it, then you know that there is only one modal number, which is 79. Then you know the data is unimodal. Otherwise, if we could have two modal number, it will be bimodal. If we could have multiple modal numbers, then it will be multimodals. That was all about the mode, measures of locations. Thank you for listening and stay tuned for more.